Hi everyone, my name is Jayant, and I'll be presenting our paper, which is DAP-LeR-DAug, which are techniques for enhanced online sexism detection. So before going into the detail of the architecture, I'll just like to discuss the motivation aspect. So as we all know that in today's world, social media platforms have gained a lot of ground, and there's a lot of digital communication happening. And this all nevertheless brings about an increase in hate speech also, especially in the form of sexism. And this type of content will always have devastating effects on the psychological well-being of the users. And the point where our paper comes in is that human moderation alone will never be sufficient to monitor this large volume of content. And that is why there is a need for efficient automated solutions. So let me just introduce you to the tasks. So this task was presented in Semeval 2023 workshop. And the task goes like this, that we're given an input and there's a series of subtasks that our system has to perform. So task A is simple binary classification, whether the post or the content you're given, whether it's sexist or not sexist. And then you have task B, which are different major categories of sexism. And in task C, we have more fine-grained subcategories of sexism. So the difficulty of task progresses as we go deeper into the subtasks. So coming up to the system architecture, right? So first of all, our system can be broken into 5 different parts. One of them is the baselines, which will fine tune them and just run them as it is. And then we have a model for each of the techniques, DAP, LeR, and DAug. And the final one is the ensemble model in which we combine all the 3 techniques together. So for the baseline models, we have selected three BERT-based models: Roberta, HateBERT, and BERT-Tweet. So Roberta is basically BERT, which is extensively trained with larger batches and more data. I'm sure most of you are familiar with it. And HateBERT is basically a BERT model which has been pre-trained on a lot of hate speech data. It has seen a lot of corpus filled with hate tweets or hate posts from Reddit, like that. And then we have BERT tweet, which is explicitly trained on Twitter corpus. BERT trained on entire Twitter corpus, so it has representational learnings for the informal sort of language that people interact on Twitter. So now coming to the detail of the first technique, right? Domain adaptive pre-training. It's probable that most of you know a lot about it already. So the point where this technique comes in is that the organizers of the task, they had provided an additional data set apart from the training and testing data set. And this data set was basically 2 million unlabeled posts from Gab and Reddit, which the organizers felt satisfied the sexist, or basically from forums that are usually tagged as sexist in Reddit and Gab. So what we have done is that we have utilized this data set with the mass language modeling objective. And what we basically do is we get rid of useless tokens like usernames, hashtags, URL, which do not really contribute semantically. And then we randomly mask a certain percentage of the sentence. So basically the model will learn by predicting the mask tokens, and our goal will be to minimize this loss between actual and predicted tokens. So this was a DAP technique. Now we come to learning rate scheduling, which is the second technique. So basically it is not, as you'll say, like an NLP technique as such. It is more with the basics of machine learning, but we still wanted to give it a try nevertheless. So what it does is basically it enhances the model performance by dynamically adjusting the step size during training. So initially what happens is it allows larger parameter updates, and as training advances, the learning rate is reduced so that it stabilizes the optimizations and we're able to prevent overshooting. And in terms of setup, we experimented with 4 different learning rate scheduling techniques: step decay, exponential decay, cosine annealing, and one cycle LR. And what we saw was that more or less all of them were performing the same, but cosine annealing was basically edging out the other techniques in some of the aspects in which we were using ensemble model. So we decided to stick with cosine annealing when we report the results. And this is the final technique, data augmentation. So one thing that we noticed during the data set analysis stage was that task data set was very highly imbalanced, right? So for subtask A and B, majority class had 3 times more instances than the minority class. And for subtask C, the situation worsened. So in subtask C, we noticed that the minority class did not even have 100 examples, while the majority class out of those 11 classes had like more than 700, 800 examples. So you can see that the model is very prone to bias here. So we had to take care of it. And for this, we followed an easy data augmentation approach, which was introduced by Wei et al. In 2019. And it basically gives some steps, to generate more examples. Some of them are synonym replacement. So we can replace words with the synonyms, or we can randomly insert words that are semantically closer to it. And we can swap words, or we can randomly delete words, right? And create more examples. So for creating this extended data set, we've used Roberta model because it was giving semantically more related examples to our data set than we saw with the hate BERT and BERT tweet. And we set the augmentation probability to 0.3 because more than that, it was giving very noisy examples. So that was that. And now coming to the ensemble model. So this is pretty self-explanatory. We basically combined all the three different techniques together. And we felt that it should ideally outperform all the individual techniques that we've seen till now. Now, just a brief about the fine-tuning setup for the data set. So we did a 85 and 15% split for training and validation. And for testing, a separate data set had been provided by task organizers. We decided to stick with it so that we can compare how our system stands with the top ranked systems of the task. And in terms of pre-processing, we took care of certain extra steps like removing hashtags, emojis, and there are some noisy tokens in informal languages, right? Like writing hey with y extended multiple times, u, etc. And for classifier training, we have basically done 10 epochs with batch size of 16. So yeah, just to give you a brief recap, so this will be our baseline BERT-based model, which will be Roberta, hate BERT, or BERT tweet. And the baseline flow is pretty similar. We'll just use it, fine tune it on the dataset, evaluate. And we have DAP and DAG techniques individual. And then we have X1 in which the extended dataset from DAG comes in. And there's also domain adaptive pre-training. And during pre-processing and finally training stage, that is where the LER technique comes in. So now basically talking about the results. So in results, we saw basically two major notice. We noticed two major things. And one was that basically DAP technique, it was performing really good for task A, for binary classification. So if you can see, it gives the highest jump from the base model. Whether you take Roberta or you take HateBird, it gives the highest jump when compared to LER and DAG. And for task B, the same was true for learning rate. Although DAG techniques also comes very close to LER, but still LER edges out in almost all of them. And finally, for task C, data augmentation performed the best. And when we look at the ensemble model is the best of all, whether it's baselines on the individual models. And finally, the Roberta ensemble model outperformed all of the ones that we tried. So this was the major thing. And also when we compare to the initial task paper, right? So basically the best baseline of transformer models that was set in the paper, our Roberta ensemble model was able to comfortably beat that. However, it was not the top ranked system in each of the subtasks. And another thing to notice over here is that the top ranked systems for each of them are from different teams. So there is not a single team which could come up with a technique, a single technique which would give very nice results in each task. So this score is from a different team, this score is from different team, and this one is from different team. So basically what we wanted to try is that if we could figure out a one single technique or group of techniques, that could give a very large boost about the best baseline set by the task paper. So this is what we tried, and we were able to do that. So in conclusion, we were able to demonstrate that each technique works well for each subtask. And when we combine them together, they complement each other. And yeah, they were able to comfortably beat the baselines of the task paper as we discussed. And we feel that we can try these techniques to the classification problems also, like the detection of general hate speech and this fake news, legal document classification, sentiment analysis, etc. So I'd just like to conclude with a few points for limitations and future work. So one of them is obviously, like we can try larger versions. So Roberta XL or XXL, which will basically give, increased vocabulary and parameters. And then obviously this is one of like very greedy solution, but if you could have like more data always for machine learning, that would be good. So for the DAP stage it will work out really well. And instead of in terms of pure machine learning, instead of focusing on learning rate alone, we could think about optimizing the dropout rate and try out with different loss functions, focus on weight decay and activation functions as well. And for data augmentation stage, we can try out the approaches also. For like example, back translation. So let's say like I could translate the English example into Romanian and then back translate into English. So that would give me basically another example for the same kind of content. And lastly, in the pre-processing stage, we were removing hashtags and emojis. And however, we can try to include them, which will give us a better understanding and vector representations for our models, as Eisner et al. Had shown in their work in 2016. And emoji 2x and hashtag segmentation was two things that they were able to utilize, and they showed that they really like give a boost in the performance in the results. So yeah, that was it from my side. Thank you. If anybody has any questions.